Hello students, today we'll continue with exercise 6.4 and in this session we'll understand question number 2 and question number 3. Now in question number 2 one figure is given RPQ and in the middle of and inside this triangle one point is given which represents O. Now related to this figure they have asked 3 questions. Okay, now you have to answer that whether it is possible or not, whether it is true, whether it is false, or yes or no. In any format you can answer. Now let's check out the first one. OPOQ. OPOQ. We don't see any connection is there. So the first thing that we will do is you will make the connection with O and P, that is like this. Just make a dotted line. Now we have a connection OP. Now OQ and just make a connection this also. Okay. So this is how they are connected now. But when we are doing this, you see some interesting facts is happening. We are getting 3 triangles. One triangle is OPQ, another triangle is ROQ, and the third triangle is ROP. These are the 3 triangles we have achieved after we have connected R with O, P with O, and Q with O. Isn't it? Now you see the first expression that they have given. It is related with this particular figure. Okay, so in triangle OPQ, in triangle OPQ, so we know that we have learned also in our previous video that the length of any 2 sides of a triangle is always greater than the length of the third side, isn't it? So just what we will prove. So see, OP plus OQ. So when we are adding these 2 lengths, so the length of the sum of these 2 lengths of a side will be always greater than PQ, isn't it? So it is quite true. So OP plus OQ, OP plus OQ will be greater than the third side, that is a PQ. Reason is length of any 2 sides of a triangle is greater than the length of the third side. So this is the reason. So it is true. So it is quite true. Now let's check out with this one. OQOR. OQOR. That means we are talking about this particular triangle, isn't it? That is greater than QR. So in triangle ROQ, OQ plus OR is greater than QR. Same reason. You will give the same reason out here. So it is also yes. It is also possible. Now let's check out the third one. OROP. OROP is greater than RP. So this is the figure. So in triangle, what is the name of the triangle? ROP. ROP. It is quite possible that the sum of the length of the 2 sides will be greater than the third side. So sum of these 2 sides will be greater than this side. So it is quite true. So again you will give the same reason out here and you will write yes. Okay. So all the 3 cases are true. So this is how you will do question number 2. Okay. Let's move on to sum number 3. This is sum number 3. Now let me explain you what question number 3 is saying and what exactly you have to find it out. Now this is a triangle, you can see ABC. Okay. Now in this triangle they have said that AM is a median. You remember median, students? That is BC has its midpoint, that is M. Now from midpoint, when we draw a line to the opposite vertex, this line is called what? Median. Okay, so AM is a median, M is a midpoint of BC, so BM is equals to MC. Okay, this is given, AM is a median. Okay, now what exactly you have to find out or you have to show? That is AB plus BC, that is AB plus BC plus CA is greater than 2AM. Okay, now to find this out, we have to first of all see this triangle ABM. Now see solution. In triangle ABM, Okay, now sum of these two sides will be greater than this side. Now we have learned this, that is AB plus BM is greater than AM, isn't it? So this is the first expression now we have got. Now another triangle, we'll also work out on the another triangle, that is AMC. Now similarly, in triangle AMC, AC plus MC is greater than AM. This is number 2. Okay, now we'll add 1 and 2. Adding 1 and 2, we get. Now how to add this? This is the question. Now what we'll do is that, you see this greater sign on the left hand side, this is the left hand side, and towards the right hand side, it is towards the right hand side of this figure is these are on the right hand side, and this is the left hand side. So left hand side should be added with the left hand side, and the right hand side should be added with the right hand side. So AB plus BM plus AC plus MC, these are all on the left hand side, and these are on the right hand side. So I'm repeating that when you're adding these two in equations, then you have to add the left hand side with left hand side, then you will give the greater than sign, then again you will add right hand side with right hand side. So see, I'm doing this. So AB plus BM, okay, plus AC plus MC. So left hand side plus left hand side. Now I will give greater than sign. Now right hand side plus right hand side. So what is there in the right hand side? AM and this AM. Okay. Now you see what we have to prove. AB is there. Okay. BC is not there. CA is there. Yes, CA is there. That means we have to remove this two. AB is there. AC is there. CA and AC are same only. We have to bring BC. That means we have to remove this two. In place of this two, we have to write BC. And on the right hand side, we have 2 AM. So how many AM we are having here? AM plus AM what? 2 AM. So now what we'll do is, see, AB plus CA is there, and we'll bring this two together. That is BM plus MC. We have to remove this, or we have to bring BC in place of this. Now AM plus AM is what? 2AM. Everything is settled. Only we have to settle this one. Now BM plus MC. Is it possible that in place of BM and MC we can write BC? Let's see the figure. BM plus MC, isn't it? The length of BC can be written as a BM plus MC, or in place of BM plus MC we can write BC, isn't it? Now it is possible. So AB plus CA. So in place of this, the sum of these two line segment is equals to BC. So we'll write BC. So here is your required expression. Fine. So this is the expression, or this is the solution of question number 3. Okay. Thank you. So today's session is only question number 2 and 3. Fine. Thank you and take care.